Hello everyone, this is Vincent Tori Bongolan, a data scientist by profession with more than 17 years of experience in technology and analytics. I am currently working for the Asian Development Bank as a senior data scientist and artificial intelligence lead for innovation. I am also a faculty, a lecturer at Polytechnic University of the Philippines, Arellano University, and De La Salle College of St. Benilde. I am also a book author on research and statistics, a contributing author on different e-learning platforms such as Udemy and tabletwise.com. I am also a speaker. I am also a founder president of Data Engine Training and Consultancy and the eTech International. After graduation, I was able to land my first job at the National Labor Relations Commission as a statistician. I stayed for 1 year at the National Labor before transferring to Manila Teachers Savings and Loans Association as a corporate statistician. After 2 years, I transferred to Arellano University as the university statistician and at the same time a faculty where I teach statistics and research subject courses. And because I enjoyed teaching, I stayed at Arellano for almost 6 years before joining to the Nielsen Company as a senior data science executive. I stayed for 2 years at the Nielsen Company before transferring to Service Seeking Australia as a senior business intelligence manager. I stayed for 1 year at a Service Seeking Australia before transferring to Integrion Managed Solution as a senior investment research analyst. After a year, I flew to Kuala Lumpur, Malaysia to work as a senior data scientist at the Center for Applied Data Science. Prior to Asian Development Bank, I was the Senior Data Science Associate Manager of Accenture Philippines. Alright, so this is my brief background of my careers. Alright, so in this video, I'm going to discuss how can we process raw data to make it more insightful and to produce insights. Alright, so how to do this? We are going to discuss the frequency distribution. Alright, so a frequency distribution in statistics is a graph or data set organized to show the frequency of occurrences of each possible outcome of a repeatable event observed many times. A frequency distribution can be graphed as a histogram or pie chart. For large data sets, the step graph of a histogram is often approximated by the smooth curve of a distribution function, which is called a density function, when normalized so that the area under the curve is seen to be bell-curved or having a normal Gaussian distribution. Frequency distributions are particularly useful in summarizing large data sets and assigning probabilities. A frequency distribution, on the other hand, shows a summarized groupings of data divided into mutually exclusive classes and the number of occurrences in a class. It is also a way of showing unorganized data, notably to show the results of an election, an income of people for a certain region, sales of a product within a certain period, student loan amounts of graduates, etc. Some of the graphs that can be used with frequency distributions are histogram, line charts, bar charts, pie charts, and many others. Frequency distributions are useful for both qualitative and quantitative data. In statistics, a frequency distribution is a list, table, or graph that displays the frequency of various outcomes in a sample. Each entry in the table contains the frequency of count of the occurrences of values within a group or interval. In addition, a frequency distribution is the organization of a dataset into contiguous, mutually exclusive intervals so that the number or proportion of observations falling in each of the interval is apparent. A frequency. Frequency is the number of occurrences of a particular item in a set of data. There are three reasons to construct frequency distributions. So why we need to construct a frequency distribution? Of course, through frequency distributions, we can assist with choosing the appropriate test statistics, whether it is a parametric or non-parametric statistics. We can also able to transform ungrouped data set of data into a grouped data. We can also assist with identifications of outliers. Data are summarized into a frequency distribution to make the presentation meaningful and to facilitate the analysis. A frequency distribution can show patterns of variation which are important in making policies and decisions both in economic and business matters. A frequency distribution, on the other hand, deals largely with quantitative observations. So this is an illustrative example. So the following data is a result of a sample survey regarding the behavior of 30 students of BSIE 3-2 inside the classroom. The letters A, B, C represent the three categories. It's either excellent, fair, and poor. Alright, so the solution is this. The categories are the letters. Record these categories in the first column, then read each result from the given data and mark a tally, denoted by L or I in the second column next to the corresponding category. Right, so the tallies are marked in blocks of 5s for counting convenience. Lastly, record the tallies for each category in the third column. This column is called the column of frequency. Alright, so the category are ABC, which symbolizes the excellent, fair, and poor. Alright, so the tally, as you can see, and the frequency is just the count of the tally. Okay, so the solutions. So this is an array. So this is another example. So 888, 9999, 888, and so on and so forth, up to 15 numbers. So steps in constructing a frequency distribution table. The first thing to do is to determine the range. Range is the number of the value or the difference between the highest value and the lowest value in a distribution. So in this particular example, we will going to see and identify the highest value and the lowest value. So as you can see, the highest value is 15 and the lowest value is 8. So to compute for the range, we should get the difference between 15 and 8. Okay, so the second step is to determine the desired number of classes or class interval. Alright, so in this particular steps, there are actually 3 considerations to do. Alright, so there are 3 approaches or steps or procedures on how to determine the desired number of classes or class interval. So the first approach is the 2k approach. Under this approach, the result of the 2 to the k power should be greater than the range, which is k, and is denoted as the number of classes. So k denotes as the number of classes. So I'm going to discuss this later in this video. The second approach is the logarithmic approach. Okay, so this approach is subjective or should be based from the total number of observations. So as you can see, the formula is this: 1 plus 3.33 logarithmic of n. Alright, so n is the number of observations. And the last is the a priori approach. Under this approach, the researcher sets a predetermined desired number of classes for the set of data. Alright, so since this is a priori approach, this is dependent on the researcher's or the analyst's choice. So we can use either 5, 7, and 9 depending on the number of items or number of sample. Alright. Number 3 steps in constructing a frequency distribution table is the class width. So you have to calculate or compute the class width. The class width is the difference between the upper class limit and the lower class limit. To compute for the class width, simply divide the range over the desired number of classes. Alright, so this is how the width is computed. Okay, so next is we're going to discuss the different parts of a frequency distribution table. Alright, so to present the data in a frequency distribution table, there are parts or columns required to form part of the table. Okay, so the first is the class interval or the class limit. It must take into account the manner of measurements when setting off intervals. It is always start from the lowest score and consider it as the first lower class limit. Then add up the computed class width to the first lower class limit, which includes the lower class limit as your starting point. Do this successively until you reach the interval where the highest value belongs. The second is the construction or counting of the tally sheet. So the tally column simply consists of the tally for a specific class interval upon which a certain observation belongs. So this is like during the election period. So when the election canvassers just write the somehow a symbol which symbolize the number of voters. So this is a tally sheet. The third is the conversion of tallies into frequency by counting the number of occurrences. Simply transform the tallies into numbers to give a quantitative representation to the frequencies per class interval. So meaning to say, if you have a tally of XX, XXX, so the tally is 5. Okay, so the frequency of this symbol is 5. All right. Next is the midpoint or class mark. Okay, so midpoint and class mark is denoted as MID point or just an X. All right. So the point halfway between the class limits or the class boundaries is called the class mark or midpoint. This is the average between the upper limit and the lower limit. So midpoint is given by this formula. X is equal to L1 plus L2 divided by 2. So meaning to say, the lower limit plus the upper limit divided by 2. So this is how a midpoint or class mark is computed. So this is like the median. Alright, so the next is the cumulative frequency less than. So determine the less than cumulative frequency by getting the frequency of the lowest class and add it successively to the frequency of the other classes. Next is the opposite of the less than. So this is the cumulative frequency greater than. Determine the greater than cumulative frequency by getting the frequency of the highest class and add it successively to the frequency of the other classes. The relative frequency distribution and the percentage frequency distribution. The relative frequency distribution is simply the ratio of the number of observations in the interval to the total number of observations, known as the relative frequency. The percentage frequency distribution is arrived by multiplying the relative frequencies of each of the interval by 100%. So the relative frequency distribution can be calculated based from the quotient of a frequency and the number of observations. And the percentage frequency distribution is that this is the product between the relative frequency distribution and the 100. All right, so this is the RFD and the PFD. Okay, so this is the illustrative example. Okay, so the frequency distribution table. All right, so given below is the scores in a unit test in statistics of 50 students of Bachelor of Science in Accountancy third year, section 1. So the given data is 50 students. All right, so this is the scores in statistics course. First is to compute the range or determine the range. Range is the difference between the highest value and the lowest value in a distribution. So as you can see, the highest value is 91 and the lowest value is 27. So the range is 64. Next is determine the desired number of classes or class interval. So as I mentioned a while ago, there are 3 approaches in determining the number of classes or class interval. Alright, so we will be applying first the 2K approach. So under this approach, the results of the 2K should be greater than the range. Okay, so this is the requirements. When we are going to use the 2K approach, the 2k should be greater than the range. Okay, so the resulting value should be greater than 64. Okay, so this is how to determine the number of classes. So the resulting answer should be greater than 64. All right, so 2 to the 7th power is 128, which is greater than the range. Therefore, the desired number of classes is 7. Alright, so that is the number of classes. Next is the logarithmic approach. So under this approach, so as I've said a while ago, this is somewhat subjective and should be based from the total number of observations. So the formula is that C is equal to 1 plus 3.33 logarithmic of n. So as I've said, n is the number of observations. So C plus 3.3 logarithmic of 60 is equal to 6.86, and if we round off, this is equal to 7. So this is quite similar to the 2k approach. Okay, so the result is 7, or the class interval is 7. All right, so the third approach is the a priori approach. All right, so under this approach, the researcher sets a predefined desired number of classes for the set of data. So it depends upon the analyst. It depends upon the researcher. Okay, so since based from the two procedures and approaches, the number of classes should be 7. Therefore, we can also use 7 or any odd number that we want to use, because this approach has no underlying rules or principles. So since the results for the approaches using the 2k approach, using the logarithmic approach is the same, so there is no also an objection if we are going to use 7 as the number of classes under the a priori approach, right? The next is the compute for the width or the class width. The class width is the difference between the upper class limit and the lower class limit. To compute for the class width, simply divide the range over the desired number of classes. Okay, so the range, if you remember, is 64, right? And the desired number of classes is 7. Alright, so the class width or the class interval should be 9.14 or simply 9. Alright, so in this option or in this portion, we can actually use 2 decimal places, or we can convert it to a whole number. So in this case, we can use the whole number such as 9, exact 9. Alright, so if we are going to use the 9.14, then we can use the 2 decimal places. Alright, next is the components or parts of a frequency distribution table. Okay, so this is what I have discussed a while ago. The classes or class intervals, this is the number of groups that does have a lower and upper limit. Intervals for each of the groups should be the same or equal. Write the lowest value in your column for the classes. Add the computed class width from the lowest value. So to compute for the next classes and 1, add 1 from the upper classes. Second is the tally. This is the manual tally of the number of occurrences that falls on each of the groups. The frequency is the numerical value that was exhibited in the tally. So this is the numerical value of the number of observations or occurrences. The midpoint or the class mark, so this is represented by the symbol X. This is the median value of the classes. This is the resulting value when you add the lower limit to the upper limit and then divide by 2. The midpoint or class mark. So as I've said, this is represented by the symbol X. Alright, so next is the class boundaries. The class boundaries are the data values which separate classes. The lower class boundary of a class is defined as the number of lower limit of the class in the question and the upper limit in the previous class. The upper class boundary is defined as the average of the upper limit of the class in question and the lower limit of the next classes. Next is the cumulative frequency. This can be obtained by adding successively the frequencies of all the previous classes. The relative frequency distribution can be obtained by dividing the frequency of the classes by the total number of the given set of data in a distribution or a data set. Alright, so this is the actual example of a frequency distribution table. So alright, so as you can see, the classes is 27. So 27 to 35 is how many intervals? 27, 28, 29, 30, 31, 32, 33, 34, and 35. So if you remember, the class interval should be 9. So therefore, 27 plus 9 is 35. So you should include 27 when you count the classes. Alright, so the intervals are mutually exclusive. So 36, 37, 38, 39, 40, 41, 42, 43, and 44. So there is an interval of 9. The tally, so meaning to say, for based on the given data, for the 27 to 35, there are 3 participants. Alright, so X, how to compute 31? Okay, so 27 plus 35 divided by 2 is 31. Alright, so the less than frequency distribution, or the less than cumulative frequency rather. So let's just copy the frequency of the lowest class. Okay, so the lowest classes or the class interval is 27. So therefore, copy the frequency of these classes, so which is 3. By looking at the frequency part, the symbol is F. So let's 3 plus 9 equals 12. 12 plus 9 is 21. And 21 plus 11 is 32. 32 plus 12 is 44. 44 plus 8 is 52. 52 plus 5 is 57. And 57 plus 3 is 60. So there are 60 participants. Alright, so the greater than cumulative frequency can be done on the opposite of the less than. So we will start counting from the classes with the highest number of intervals. So we will copy the frequency for these 90 to 98 classes. Alright, so 3 plus 5 is 8, plus 8 is 16, plus 12 is 28, plus 11 is 39, plus 9 is 48. 48 plus 9 is 57, and 57 plus 3 is 60. Alright, so the relative frequency distribution. Alright, so the relative frequency distribution can be computed by this procedure. So looking at the frequency, okay, so the symbol is F. So 3 divided by 60 is 0.05. 9 divided by 60 is 0.15. 11 divided by 60 is 0.18. 12 divided by 60 is 0.20. 8 divided by 60 is 13.13. 5 divided by 60 is 0.08. And 3 divided by 60 is 0.05. Alright, so to calculate the frequency, the percentage frequency distribution, so simply multiply the RFD by 100 and you will get the 5, 15, 15, 18.33, 20, 13.33, 8.33, and 5. So when you sum up this relative frequency distribution, this always equal to 1, while the percentage frequency distribution always equal to 100. Alright, so this is how to transform raw data into a grouped data. Okay, so watch out for the other videos. Thank you, and please subscribe to my